Hello, Business 270. This is Professor Hassey. This is our week 5 weekend update video to finish out the week of study. Right this weekend, you're working on a paper entitled Sample Distribution and versus Population Distribution. It's an analysis or a sampling of analysis, and you are to answer questions and respond and interpret the data provided. That paper is due Sunday, September 25th. If you need an extension and some extra time, no problem. Just let me know and that can be arranged. No worries. I want to talk a little bit about that question of sampling distribution of the sample mean in this weekend update video. The sampling distribution of a sample mean is a probability distribution consisting of possible samples and their averages, their means of a given sample size selected from a population, which is the problem that you're looking at with the Mid-Motors Ford this week in your paper. For example, the sample distribution of these 7 hourly employees are as follows, and we looked at this in our earlier video this week, where you take a sample of a group of a population. In this case, the population is the TARDIS industry, and you take a look at their hourly ratings. And you want to determine what is the population mean, what is the mean of this, now do a sample of this population into a sample size of 2, kind of like the frequency distribution we did way back in week 1 and 2, where you had a frequency distribution of sample sizes. Now we're taking a sample size of 2, and what is the mean of that sampling distribution? And what observations can be made about the population and the sampling distribution? Very similar to what you're working on in your paper this week, week 5. So by taking the population, the entire group of employees, you find that the population mean is 7.71. And now if I wanted to arrive at a sample distribution of the mean, we need to select the sample sizes of 2 and then compute the means of those 21 sample sizes. And here they are here. Remember, the population mean is 7.71. So here are all the different employees grouped by 2 and their hourly earnings and what the average or the mean of those various 21 of those 7 employees sample sizes. So again, what we're doing here is we're taking a population and then we're doing a sample by 2 employees to see what does that tell us. And by doing that, we can determine a sample distribution of how many had sample means of 7, 7.5, 8, and 850, and we put together a probability analysis of those 21. In other words, if looking at this, that most of the hourly rating or earnings go, or like 43% of them go at $7.50 an hour. So that tells us something. At the same time, we can also determine the sum of all the sample means, taking all those sample means and dividing it by the number of samples, 21, and we come up again with 7.71. So the sample means also total the population means, exactly the same. And then we can put it into a distribution by the population or distribution by the sample. You can graphic, and it'll tell you about the slope of the curve. Notice here, you can almost do a curve here. You could just do the curve, almost like a bell curve, which tells you that that sample is a good one. It's a bell-shaped curve. So in other words, the key thing to get out of this is, and we've been talking about it the last week, is making sure if you have a population and you want to take a specific sample of that population, how has the mean the mean of that sample differentiate from the mean of the overall population? And if you chart that, is that mean distributed in a bell-shaped curve or some other type of curve that show the skewness of the data? I wanted you to tell me in your paper, is this data of this paper of the Mid-Motors Ford, What can you tell by that data and the sample means? Is the data skewed or is it a bell curve? I want you to explain that to me by looking at that data for the paper. Because that brings us to the central limit theorem, which is one of the key theorems that you need to take out of chapter 8. If a population follows a normal probability distribution, then for any sample size, the sampling distribution of the sample mean will also be normal. So if you have a population that has like the problem we just saw, a 7.71 mean, and then do a sample with a sample size of 2, a sample analysis of that population, and that sample size or sample mean is also 7.1, that tells us by the central limit theory that this is a normal distribution, meaning the data is accurate, right on the money. According to the sample is just like the population. So it's right on the money. That's a good thing. A lot of times when you do a sample, if it skews either way, positive or negative from the average or mean of the population, that tells you that there's the standard deviation or the distribution is a little bit different. And that tells you the sample size is a little bit skewed or off. And is that data reliable to go by? So that's what we're talking about here. And that's what you're pulling out of this paperwork this weekend. And that's what you're taking out of this for week 5. Next week, we're going to begin our discussion of hypothesis testing in chapters 10 and 11, but also we're going to have a paper, and the paper is going to backtrack a little bit to chapter 6, and it's going to talk about probability distribution, a little bit like what we did in the sampling side in chapter 8 in the paper you did this weekend, but I want to go back and go through that on taking a look at deviations and the calculations of deviations, and a little bit more specific and setting us up with that paper for next week and the paper of this week to get us ready for the end of the course and hypothesis testing. So remember, a probability distribution is a listing of all the outcomes of an experiment, the probability associated with each outcome. The characteristics of a probability distribution are you either have is between 0 and 1. The outcomes are yes or no, black or white, whatever. A drug manufacturer may claim a treatment will cause weight loss of 80% of the population. This claim can be tested by a consumer protection agency using a sample and statistical inference. What does that mean? Meaning that you can do a test of the sample and the outcomes of which you're looking at a test in your paper this week in week 5. Suppose we're interested in the number of heads showing up with 3 tosses of a coin. There can be no heads, 1 head, 2 heads, or 3 heads. So if we coin toss, what are the possible combinations that we can get from a probability distribution of tossing a coin? Let's see, the one out of those chances, 1 out of 8, you have 0 heads. The probability of 1 out of 8 of getting 0 heads, 3 out of 8 of getting 1 heads, 3 out of 8 of getting 2 heads, and 1 out of 8 getting 3 heads. So there's the probability distribution. Notice how the sample is. Notice again this nice sweeping bell curve, which tells us that it's a pretty good analysis. Those are pretty good probabilities. 12.5%, 38.5%, 12.5%, and so on equal a total of 1. So in other words, flipping a coin and getting heads, tails, or heads or tails, this is the likelihood that this could happen. So it means it's a good analysis. This is called a random variable test, where the experiment can have different values. Yes, the different values are heads or tails, but that it's random. You don't have any control of setting what that is. One type of random variable, and we've looked at this, is a discrete variable, meaning that it consumes certain clearly separated values. In other words, flipping a coin is a discrete random variable. And here's the frequency of that happening. A continuous random variable is a variable that may change, assume in an infinite number of values. I mean, in other words, there can be many, many different values or variables in outcomes. Whereas a discrete is it's limited to you're either male or female, heads or tails. Here, the time between flights between Atlanta, LA could go. You could have different times all the time because of weather conditions, flight schedules, whatever. That's a continuous random variable. So the mean is a typical value to represent the central location of the data. You all know that. It's the average, it's the midpoint. And the mean of a probability distribution, we've done this before, totaling up the various outcomes, dividing it by the number, that's our mean. Also, the spread of that data is we're doing the variance. We've looked at a video, we've looked at what that variance represents. We've seen that in our topic in sampling. The standard deviation of that distribution is the square root of that variance. And the higher the standard deviation, it means the greater or the more skewed the data is. So here's a distribution of number of cars sold and the probability of those number of cars being sold for this car dealer by John Ragsdale. And here's the number of cars sold. You take a look at the variance in that, and there's a variance of 2.1. If you square that variance and determine the mean versus the actual variable, you get the variance analysis. So there's different outcomes to these analyses. And the variance analysis, which we've looked at also, and this is what your paper is going to be looking at, is looking at a variance analysis, standard deviation between the mean of various variables, and what does that standard deviation tell you, the student, on the quality of the data. So this is going to be your paper in paper number 3 in week 6 is taking a look at a standard deviation analysis of various variables, and is that a good analysis? Is it a good or a bell curve deviation? If it's skewed by the way the standard deviation is set up, what does that tell you about the data? So that's what we're heading into, looking at going back to chapter 6 and looking at this analysis and applying it to some data in our paper number 3. So our task at hand this weekend and heading into week 6 is to do this second case paper. The case paper will be in APA format. Don't forget, that means a title page, an abstract page, and then 2 or 3 pages of interpretation, double spaced. And if you went outside of the textbook and outside of the information provided you in Blackboard, you have to include your references for that work. And what a reference is, if you ask a fellow student or ask a colleague about this paper and the material, that's a reference. You would have to point that out in your reference page. So again, APA format, and title page, abstract page. And basically an abstract page is an introduction. In this paper, I'm doing an analysis of Mid-Motors Ford. And this is my conclusions of that analysis. And then you write about your interpretation and your conclusion of looking at that data in those 2 to 3 pages of explanation, double spaced, and then your reference section. So again, as you finish up the paper this weekend and have any questions about that format, please feel free to let me know. But there's a link in the case paper file folder in Blackboard, a link to explain the APA format, but keep it simple. Title page, abstract page, which is an introduction, and then your interpretation writing in double spaced 2 to 3 pages, and then your reference. So by all said and done, your paper should be 1, 2, 3, 4, basically 5 pages of 2 to 3 pages of actual writing, and then your title page, your abstract page, and your reference page, if you need it. But if you don't have any references, just have a reference page saying not applicable. I have no references for this paper. Okay, that's what we do heading into this week 6, and we will have a video on Monday afternoon and evening to talk about paper number 3 and our topics of week number 6. I'm available all weekend if you have any questions or concerns. Have a great weekend, and we'll talk to you next time.